हॅलो ऋषिकेश, आवाज येतोय का माझा?
हो सर, आवाज येतोय सर.
ठीक आहे. आणि स्क्रीन वगैरे व्यवस्थित दिसतोय सगळं?
हा सर.
स्क्रीन दिसतोय का माझा व्यवस्थित?
हो सर, दिसते सर.
ठीक. आपण एक आणखी 2 मिनिटं वाट बघूया आणि चालू करू.
हो सर.
तुमचं कुठपर्यंत झालेलं आहे युनिट? आता 3 झालेत का पूर्ण?
सर आता पहिला झाला, दुसरा झाला सर. आणि पहिल्या चेनला आलता सर.
पहिल्याचं काय?
म्हणजे सर 2 युनिट झालेत सर.
अच्छा, फर्स्ट आणि सेकंड पूर्ण झालेले.
हो सर.
आणि तिसरं युनिट कुठपर्यंत झाले ते आहे?
सर म्हणजे ऍक्च्युली पहिल्या युनिटच सर शेवटचे पॉइंट राहिलेले आहेत.
ओके.
ते तेवढं ते सरांनी पहिलं दुसरं युनिट शिकवलं आणि मग त्याच्यानंतर सरांनी फर्स्ट युनिट शिकवलं.
ओके. आणि तिसरं वेपर ऍब्सॉर्प्शनचं अजून सुरू झालेलं नाही.
हा नाही सर.
ठीक आहे, आपण युनिट नंबर 4 चालू करूया. सायक्रोमेट्री आणि सायक्रोमेट्रिक प्रोसेस.
हो सर.
Okay, then we'll start the discussion for the unit number 4. The
Yes, sir.
contents for unit number 4. So this can be seen on this slide. Initially, we will discuss about the introduction to the air conditioning. So that essentially includes what are the broad areas of application where we need the air conditioning, and we'll also see that how we can define the air conditioning. Because as the name suggests, that is the refrigeration and air conditioning. So half of the part, that is unit number 1, unit number 2, and unit number 3.
Yes, sir.
So that essentially deals with the refrigeration. And unit
Yes,
number
sir.
4 and unit number 5. So these are there for the air conditioning.
Yes, sir.
In the refrigeration, we know that it is the process where we are interested to maintain a temperature in some specified region, in some specified area of interest. And that temperature will always be lower than the surrounding temperature. So that is the refrigeration process. And to achieve this temperature, which is always less than surrounding temperature, ambient temperature, we continuously pump or remove the heat from that space, and that heat is rejected, dissipated to some surrounding environment. So that was the definition for the refrigeration. But air conditioning is altogether a different process. So where not only the temperature but the other parameters of the air, so that should also be controlled, that should also be regulated. Okay, so we'll see what is the definition for the air conditioning. Then it is the Dalton's law of partial pressure. So this law of the partial pressure that will be used to solve the various numericals to find out the psychrometric properties, which are nothing properties of air and water. ऋषिकेश किंवा ऋतिक, तुमचं म्यूट करा. ज्यावेळी तुम्हाला क्वेश्चन असेल त्यावेळेला तुम्ही अनम्यूट करून क्वेश्चन
चालेल सर.
क्वेश्चन विचारच्या वेळेला तुम्ही अनम्यूट करा आणि मग विचारा. So after looking into the Dalton's law of the partial pressure, we'll see what are the different psychrometric properties. Okay, so these properties are nothing but the terminology of the various properties of the air and water vapor mixture. So we'll see the definitions of the psychrometric properties. Then what are the different methods techniques which are used to calculate or find out this psychrometric property. So there are rather two different methods to find out the psychrometric property. One method is nothing but by using the graphical chart that's known as the psychrometric chart. And the another, a second method is nothing but by using some set of equations, mathematical equations, some formulas are. The formulas are derived based upon certain assumptions. We'll not discuss about the derivation of these formulas or these equations, but we'll use the final form of this equation to know, to calculate, to determine the various psychrometric properties. Then we'll be discussing about the psychrometric processes. Okay, there would be around some 6 to 8 different psychrometric processes, and these processes are used to get the final required condition of the air as per our requirement. Because you will be having the surrounding air at different pressure, different temperatures, different properties, and your requirements will be different. So your requirement of the process in summer that may be different, the winter it may be different, and it may also depend upon the what type of the application for which you are conditioning the air. Okay, so we'll be looking into those different psychrometric processes, their physical arrangement for the process, the working principle of that process, and how this process can be represented on the psychrometric chart, and some of the numerical problems which are dealing with the psychrometric process. So along with the psychrometric processes, another important term is nothing but the bypass factor of the coil. So this coil may be either heating coil or it may be the cooling coil, depending upon the heating application or the cooling application. So you may use a different type of the fluid. Let us say a cold refrigerant is used for the cooling process, which will be passed through the coil. Or you may have the hot gas, hot steam, or any other waste heat that will be circulated through the coil if our requirement is for heating application. And one of the important parameters for that coil is nothing but the bypass factor. So we'll see what we mean by the bypass factor and what is the effect or impact of this bypass factor on that particular psychrometric process. So there are the different sensible heat factors like that of the RSHF. So that is the room sensible heat factor. Then GSHF, that is the grand or gross sensible heat factor. Then ERSHF, effective room sensible heat factor, and room apparatus dew point, or also known as the RADP. ADP stands for the apparatus dew point. So we see what are these different sensible heat factors and how these sensible heat factors can be calculated, and what is the importance of these different sensible heat factors while plotting the various psychrometric processes on psychrometric chart. And toward the end, it is the theoretical topics of requirement of the comfort air conditioning, then the requirements for the summer as well as the winter air conditioning, then the definition for the effective temperature and the representation of these effective temperatures on chart, that is known as the comfort chart. And on that comfort chart, there is some specified region, space or zone, and that zone, that region is known as the comfort. So we'll see what is the
हॅलो
description
हॅलो सर
of that comfort.
एक्सक्यूज
Yes.
मी सर तुमचा आवाज ब्रेक होत येतोय असा
मध्ये मध्ये ब्रेक होतो का?
हो सर
ठीक. कदाचित तो कनेक्टिव्हिटीचा थोडा इश्यू म्हणजे असू शकतो
हा
माझ्या.
सर आता 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 येतोय सर
ठीक ठीक. So these 6-7 points are nothing but the contents which are involved in the unit number 4, psychrometry and psychrometric process. Okay. So as I stated initially, that is the introduction to the air conditioning. So we should be aware of why the air conditioning is required. Okay, what is the importance, what is the necessity of the air conditioning in our daily life. So one should not understand that air conditioning is used only for the comfort of the human being, the thermal comfort of the human being. The usage of air conditioning for the thermal comfort of the human being is only one of the applications. Okay, it is not the only application. So as such, I have just broadly mentioned three different areas of the application, out of which the first is the comfort of the human being. So the air conditioners are used for the household applications, that is your window air conditioner or the room air conditioner that we call, or in modern day we also see the split air conditioner. So these air conditioners are basically for the comfort of the human being. Then different offices, okay, commercial offices, in mall, multiplex, theater, as well as the air conditioned vehicle, that is air conditioned car, air conditioning buses. So these are day-to-day applications that one can see in our life. And in all these applications that are stated here, all the examples which are mentioned here, where the human thermal comfort is of prime importance. So that's why it is called as a, for the comfort of the human being. Whereas other that I have mentioned here, the commercial applications. So that is nothing but the cold storages. So cold storages are nothing but a big warehouse which is a condition according to the requirement, and where the comfort of the human being is not important, but it is what the product, let us say a food product that you are going to store in that cold storage, that is important. It means that let us say I have to store thousands of tons of the vegetables, I have to store thousands of tons of the food grains, I have to store, let us say, hundreds and thousands of liters of milk, ice cream, or fruits. So these are all nothing but a perishable products, isn't it? So if I store them at very low temperature, so their shelf life can be elongated and they can remain fresh. Their aroma, their taste can be retained for the longer duration if they are stored, they are preserved at very low temperature. So to preserve such food products at commercial level in large quantity, bulk quantity, hundreds and thousands of tons, so we need the cold storage. Then the operation theater. Absolutely, the indoor air quality for the operation theater, that should be of the highest order or the highest purity rather. It should be free from any bacteria, any viruses, or any such microorganisms, isn't it? So the cleanliness of the air in operation theater, that is of highest priority. Then some of the applications, that is printing and photography. So this printing and photography is normally done with the help of ink, and ink is nothing but the fluid that is likely to flow, isn't it? So ink should not get spread over the paper on which it is going to be printed at some specific temperature, isn't it? So to have the proper printing quality, the ink should have appropriate viscosity. So this appropriate viscosity, desirable viscosity, that can be maintained at some specific temperature. Okay, so that specific temperature can be obtained by the air conditioner. The third area of the application that I mentioned here, the industrial application. So like that of the cotton industry, machining of the precision instruments. That you have seen the precision instruments in the metrology and quality control lab, isn't it? Micrometer, screw gauge, vernier caliper, then height gauge, then various go and no go gauges, isn't it? So all these are nothing but a precision instrument, slip gauges, isn't it? Then sign bar. So all these are nothing but the measuring instruments where the accuracy is of prime importance, highest priority. So the machining of such precision instruments is done under some controlled conditions, controlled environmental conditions. And again here, the human comfort is not being the important, whereas the machining process is of highest importance. Okay, so these are nothing but just the broad areas where the air conditioning is required, or the air conditioning is necessary for us. Okay, is it okay up to this stage?
Yes, sir.
Sir,
Okay. Now the last paragraph here on this slide. So it states that the parameters to be regulated simultaneously for air So what parameters are mentioned? Temperature, then moisture, or salinity water vapor, or we can call it as humidity. Then parameter number 3 is the velocity, or alternative it is nothing but the motion of the air, distribution of the air, or the circulation of the air, and the quality or the purity of the air. So when we control all these parameters simultaneously, isn't it? So that process is known as air conditioning. Okay. So air conditioning can be defined as the simultaneous control of temperature of air and the moisture content in the air, velocity of the air, and quality and purity of the air. So all these four parameters are equally important as far as the air conditioning is concerned. And in contrast to that one, in the refrigeration, we are only dealing with the temperature. We are not bothered about whether the moisture is present there or not, or whether velocity has to be maintained, or whether the quality of the purity is supposed to be there. We are not interested in that. We are interested only in maintaining the temperature, nothing else. And that temperature too is less than surrounding temperature. In air conditioning, not necessarily the temperature will always be lower than the surrounding. Especially
सर
uh, uh,
सर ही सगळी प्रोसेस रेफ्रिजरेशन ऑफ एअरची आन्सर मध्ये हे होणार ना
air conditioning,
हे सगळे
these
एअर
four,
कंडिशनर हा
yes, these four parameters are controlled in air conditioning unit.
ओके
So I am just want to say here the definition of air conditioning. So definition of air conditioning is that it is defined the process of simultaneous control of number one, temperature of air, number two, moisture of the air, number three, velocity of the air, and number four, quality
क्वालिटी ऑफ एअर
or purity of.
प्युरिटी ऑफ एअर
ठीक है? So this is the
येस
definition of air. Is that okay? Have you understood the definition of air conditioning?
येस सर येस
Right. Now, if our meeting ends, then with the same meeting credentials, you should join.
येस सर
ठीक आहे? जर मीटिंग मध्ये जर संपली तर तीच मीटिंगची लिंक वापरा आणि जॉईन करा.
हो सर हो
Now we'll start with the first part of this unit number 4, that is known as psychrometry. Okay, so I hope that if you are having a notebook with you, so you should just write down this term psychrometry. What is the definition of psychrometry? Psychrometry is defined as a science or a subject or a topic or the area which deals with the study of the moisture. Okay, it is nothing but the science, it is nothing but the subject where the focus is there to know the behavior or to know about the moist air. Okay, to study the moist air. What is this moist air? Moist air is a mixture of two different compositions, two different parameters which are involved in the surrounding air. Okay, so moist air is consisting of first part, that is the dry air. Okay, first component in the moist air is the dry air, and the second component is nothing but the water vapor, isn't it? Or water vapor is known as the humidity. Okay, so moist air is a mixture of dry air and water vapor present in the surrounding air. And we know that this moisture present in the air, that will definitely change throughout the day from season to season. Okay, let us say on a particular day, let us say today. So today early in the morning, let us say at 6 a.m., so different water vapors might be there in the air. At 10 a.m., you may have some different composition, concentration of water vapor in there. In the afternoon, let us say 2 p.m., right now, let us say, your moisture would be different. So over a period of time in a day as well, the moisture present in the air that changes, and the moisture also changes depending upon the weather. Okay, so in the summer season, if you are very close to coastal region, so moisture content in the air is very high. Suppose you are there in Mumbai or Goa, Chennai, Kolkata, isn't it? So these are nothing but the cities which are very close to seashore, ocean. So that's why the moisture present in these cities is very high as compared to that of, let us say, Nagpur, which is quite far away from the coastal region. Okay, so air we can say in Nagpur is very much dry. So moisture content in the air in Nagpur is very less as compared to the moisture content here in Mumbai or Chennai or Kolkata. Right? So this moisture content depends upon season, it depends upon a time of a particular day. It also depends upon the geographical location of that city, of that town. Okay, and that definitely changes. Okay, so we are going to see here the different psychromatic properties. Okay, as I mentioned at the beginning, yes, psychromatic property. So we are going to discuss initially about the psychromatic property, and then we'll come to the Dalton's law of partial pressure. So I will now start the definitions of these various psychrometric properties. And in your end term examination, so one question is 100% there regarding the psychrometric property. You have to write down the definitions of any four psychrometric properties. Okay, any three or any four psychrometric properties, and this question is there for 6 marks. So we'll see what are the definitions of these different psychrometric properties. So first psychrometric property is the dry air. First psychrometric property is the dry air. So what it is written in the first line? So dry air is nothing but the N2, nitrogen, plus O2, that is oxygen, plus the other gases. So other gases is either carbon dioxide, hydrogen, argon, neon, helium, and so many other gases which are present in the air. Isn't it? So based upon this line, okay, based upon this line where I am highlighting now, so we can define dry air is nothing but a mixture of various gases present in the air. Okay, all the gases which are present in the air, so that mixture is known as a dry air. And we know that out of this mixture, the oxygen and nitrogen which are the major composition, major concentration is there for the nitrogen and oxygen, and followed by the other gases which are present in very small quantity. Their concentration is very negligible, maybe less than 1%. Isn't it? If we see this number, nitrogen is the largest composition, so around 78%, more than 77%, you can say to be correct, to be specific. Okay, nitrogen content in the air is more than 77% and around 78%. Oxygen is very close to 21%, and all other gases they are present in very small concentration. Okay, so major portion in the dry air is the nitrogen highest, and then followed by the oxygen, and then you are having the other gases which are present in the air. The molecular weight of this dry air is taken as 29. Okay, it is a constant. This number is constant. Molecular weight of the dry air is constant, and its value is equal to 29. And here is the gas constant of the dry air. We know the ideal gas equation, PV equal to MR. Okay, P is the pressure, V is the volume, air is the mass, T is the temperature, and R is nothing but the gas constant. Okay, PV equal to MRT. So R is the gas constant for the air, and the gas constant of the air is also constant, and its value is equal to this one. Okay, 0.287 kilojoule per kg Kelvin. Or if I want to express in joule per kg Kelvin, so I need to multiply this by 1000, and then it will be equal to 287 joule per kg Kelvin. So you have to remember this value, the value of gas constant for the air. So it may not be given all the time in the question paper. Okay, you may be asked to assume suitable value, assume suitable data if required. Okay, so you should know that what is the value of gas constant for the air. So it is always equal to 287 joule per kg Kelvin or 0.287 kilojoule per kg Kelvin. Okay, so that is your first psychrometric property definition, the dry air. Okay, Then the next property is known as the moist air. The moist air is nothing but a mixture of dry air and water vapor. Okay, it is nothing but the mixture of the dry air and water vapor. A very simple definition. The amount of water vapor present in the air that depends upon the absolute pressure and temperature. So just now I have told a moment ago that the moisture present in the air that varies from time to time. It varies from season to season. It also varies from uh, where is the location of the city, whether it's close to the coastal region or whether it is away from the coastal region. Okay, so that is the definition for the moist air. The next term is known as saturated air. So it is a mixture of dry air and water vapor. Okay, it is a mixture of dry and water vapor. When the air has the maximum amount of water vapor into it, it means that the air cannot hold any moisture after that point, isn't it? So there is some limit or there is some capacity of this surrounding air, atmospheric air, where it can hold the moisture, isn't it? So at some point of time, air will not be in a position to absorb any more moisture, and such air is then called as the saturated air, or also known as the fully saturated air. Okay, so that is the definition for the saturated air. The next definition, next term, that is known as the degree of saturation. Okay, which is normally represented by mu. Okay, in some of the textbooks, you will see that the symbol used for this degree of saturation to denote it, to represent it, the symbol mu is used. So what is the definition for the degree of saturation? So it is defined as the ratio of mass of water vapor associated with unit mass of dry air. Okay, this numerator is how much kg of the water vapor present per kg of the dry air, and the denominator the mass of water vapor associated with unit mass of dry air, which is now saturated at the same temperature. So the numerator here, it talks about the unsaturated air. Okay, how much mass of a water vapor is present per kg of a dry air in unsaturated air, and when this air is fully saturated, the ratio of these two, so that is called as the degree of saturation. And the degree of saturation is normally expressed in percentage. Okay, very important definition. The next definition is the humidity.
सर एक मिनिट, डिग्री ऑफ सॅच्युरेशनचं डेफिनेशन लिहितोय. एक मिनिट थोडीच राहील.
एक 10 मिनिटांमध्ये मीटिंग संपेल. ती संपली की आपण पुन्हा जॉईन करू.
ओके सर, चालेल.
साधारणतः 2:55 मीटिंग संपेल. एक 5 मिनिटाचा ब्रेक घेऊन पुन्हा 3 वाजता आपण चालू.
ओके सर.
ओके,
सर झालं. हो सर.
so next definition is nothing but the humidity. Okay, this humidity is also known as the specific humidity. Okay, the other term is the specific humidity, or it is also known as the humidity ratio.
रिलेटिव्ह ह्युमिडिटी सर वेगळी आली का?
Yes, it is different. Okay, we'll define also the relative humidity in next slide. Okay, so here humidity is specific humidity, or also known as the humidity ratio. So how it is defined? It is the ratio of mass of water vapor to the mass of dry air contained in the sample of air. And this is expressed as grams per kg of the dry air, or it may be also expressed as kg per kg of the dry air. And it is represented by this small w or omega. Okay, the symbol that is used to represent the specific humidity is the omega or w. So that is equal to mv divided by ma. So this v stands for vapor. This v stands for vapor, and this a stands for dry air. So mv. So that is nothing but the mass of water vapor. It is the ratio of mass of water vapor to the mass of dry air. So mv divided by ma. So that is going to be specific humidity or humidity ratio, and its unit is gram per kg of the dry air or kilogram per kg of the dry air. So we're in the same. Okay, so that is the specific humidity. The next is the absolute humidity. So it is the mass of water vapor present in 1 meter cube of the dry air. It means that how many grams of the water vapor are present per meter cube of the dry air. Hence the unit is gram per meter cube of the dry air, or if you take the mass in kg, so it is kg per meter cube of the dry air. Okay, so that is nothing but the density. Okay, kg per meter cube or gram per meter cube. So this basically nothing but the density, which is known as the absolute humidity. Okay. Then relative humidity. Okay, that is represented as phi. Okay, the symbol that is used to represent relative humidity, which is a phi. And this relative humidity is normally expressed in percentage. Okay, percentage relative humidity. So what is it? So it is defined as the ratio of, again, actual mass of water vapor in a given volume of the moisture. So in the previous slide, just we have seen the last definition. Mass of water vapor present in 1 meter cube of the dry. So same thing is represented here in the numerator. Actual mass of water vapor in a given volume of moisture, and divided by what? The mass of water vapor in the same volume if the air is fully saturated. Okay, at the same temperature. So it means that the numerator which is expressed here, so that talks about the unsaturated air, and denominator that talks about the saturated air. Okay, so that way the relative expressed. Actual mass of water vapor in a given volume of the moisture, so the mass of water vapor in the same volume of the saturated air at the same temperature and pressure. And it is expressed in percentage, 30%, 40%, 50, 60, 80%. It normally maximum value is 100%. Okay, so that is the definition for the relative. Then we will define the different temperatures. Okay, temperatures which are used in the psychrometry. So first is the dry bulb temperature, or DBT. Okay, DBT, dry bulb temperature. So it may be expressed as T sub D or T sub dB. So dB stands for the dry bulb. So it is nothing but the temperature of air which is recorded or measured by any ordinary thermometer. If you take any thermometer, so which essentially nothing but a glass tube of very small diameter, maybe around 3 millimeter, 4 millimeter diameter, and you may have a bulb at the bottom of that tube, and the scale is graduated or that particular tube, and inside that tube you may have some liquid, either you may have the mercury or you may have some red fluid which is there, and the height of the column that represents the temperature. So if the surroundings are being very hot, the height of the column is very large, so it means that it's high temperature. And if the height of the column is low in that tube, so it is nothing but the temperature is low, the cold run. Okay, so you take any ordinary thermometer and keep it open to the atmosphere. So its bulb will sense the surrounding temperature, and the column will reach a certain fixed value, and that fixed value is nothing but dry bulb temperature. So simplest definition of dry bulb temperature is it is the temperature of surrounding air measured by any ordinary thermometer. Okay, very simple definition. It is expressed in degrees Celsius. which you can further convert into Kelvin as per requirement. Then wet bulb temperature. Okay, next definition, wet bulb temperature or WBT, which may be represented as T subscript W or T subscript WB. Whatever the thermometer, let us say I have taken for measuring the dry bulb temperature, what I will do, I will cover the bulb of that thermometer with a wet cloth. I will take a wet cloth, the bulb will be covered with the help of that wet cloth, and the surrounding air will be allowed to flow over this wet cloth. So what will happen? The air will take the heat from that wet cloth, and the height of that fluid inside the tube column, so that will be lowered, and it will reach certain minimum value. So that value is the wet bulb temperature. Okay. So wet bulb temperature is essentially very important to predict the relative humidity of the air. Okay. So wet bulb temperature is given as temperature of the air measured by the thermometer when the bulb of thermometer is covered with the help of the wet cloth, and this wet cloth is then exposed to the surrounding air, atmospheric air, whose velocity is typically in the range of 2.5 meters per second, 10 meters per second. Okay, these are standard values for the velocity of the air which passes over the bulb which is covered with the wet cloth. Is that okay? So that is the dry bulb temperature and wet bulb temperature. Then the next is the wet bulb depression, WBD, wet bulb depression. So it is basically nothing the difference of about two temperatures. The two temperatures just now we defined, dry bulb temperature and wet bulb temperature. Okay, so the difference between the dry bulb temperature and wet bulb temperature is known as the wet bulb depression, and this wet bulb depression is also expressed in degree Celsius. Okay, but meeting is now just about to end, and we join after 5 minutes. Okay. So at 3 o'clock we join with the same meeting. Okay.
Yes, sir.